Alrighty, welcome. We are on worksheet 7-2. Okay, we are actually covering section 7.2 in your textbook. We are going to be simplifying radical expressions using multiplication and division. Okay, so I also wanted to tell you I updated Schoology with a PDF of the entire textbook. So the whole textbook is online from now on, okay? Instead of me taking pictures, which don't look that great, all right? So here's the deal. Things to notice, okay? When we multiply, right, use a product property here with radicals, they have to have the same index, okay? So if they have the same index, then that means we can multiply the numbers underneath, right? Or break down the numbers underneath, okay? Or vice versa. Now, we've been using this property before. Like, for example, if you remember, we had like the square root of 18. And you guys broke that down as 9 times 2, right? So you wrote it as the product of two numbers. And then because you used 9 as one of the factors, you then took the square root of 9, and that became 3 radical 2. Well, now we're going to do the exact opposite. If you see, these have an index of 3 and 3, okay? So, sorry, you couldn't quite see that, could you? Okay, so we use this idea of the product property to break down a radical into its two factors and then take the square root of the perfect square. Now we're going to do the exact opposite of that, all right? So now we're going to be given two numbers that are being multiplied by one another, okay, in example A. And so since they have the same index of 3, I'm going to multiply 3 times 9, write them underneath the same radical, and then that becomes the cube root of 27, okay? Now, that should hopefully be a number that you're familiar with. If not, you can always check it on your calculator. And weirdly enough, what ends up happening if I do math and then cube root of 27, I end up with 3, okay? So that simplifies to just a 3, just like you did when you broke down, right, the square root here. And the square root of 9 is 3, so that came out of the radical. This is the same idea here, okay? The cube root of 27, okay, is 3 because 3 times 3 times 3, 3 multiplied by itself 3 times is 27, okay? Now, similar idea with division, okay? Since the indexes are the same and these two are being divided, we can write them underneath the same radical, and then we can actually divide the two and simplify that number. So now the fourth root, and some of you, I noticed on your homework, you're writing that 4 way too big. Make sure that that looks like an index, not a coefficient, okay? So 4, just so you know, radical, written like that, is not the same thing as 4 with the little, as a subscript, I should say superscript, tucked into that index. These are two different things, okay? This one is an index. This one is a coefficient, okay? So it should be a much smaller 4. Okay, so we tucked our 4 in here. That was a bit of a side note, sorry about that. 48 divided by 3 is 16, right? And then we always want to check and see if that number is a perfect quartic, if you will, right? So if we can take the fourth root of that, so if I hit 4, math, then I go to choice number 5 and 16, I end up getting that the fourth root of 16 is 2, okay? Now, if that had been a decimal, I would just round the decimal to like the nearest 10th or 100th, okay? But right now, it is a perfect fourth root, okay? So take a look at these guys, all right? I'm gonna do these, then you guys can try these. If I take a look here, these have the same index, okay? So they have to simplify these, they have to have the same index. Otherwise, you can't do anything. So, all right, must have same index. All right, so then we're gonna do the third root of 2 times 4, okay? So then the third root of 8, okay? Now on your homework, if you write the original question, right? You don't have to show me 2 times 4, but I should see the third root of 8 not just your final answer. There should be work there. And then the third root of 8, okay, what number multiplied by itself 3 times would give you 8 is 2. Okay, you can also use your calculator. Now, if I look at this guy, same index, right? This is a 5th root. So I'm going to do the 5th root of 4 times 8, which is the 5th root of 32. And then if I do the 5th root of 32 on my calculator, what I will get is 2. Okay? So you're going to multiply them both underneath the radical, okay, whatever the index is, and then simplify. So now this guy is the third root of 54 divided by 2, and then the third root of 54 divided by 2, I believe, right? So if you do 54 divided by 2, you get 27, and then the third root of that is 3. Last but not least, right, the third root of 81 divided by 3. So we simplify, we do the division, find the quotient. So then I get the third root of 27, which you'll see the same type of numbers because there's only so many perfect cubes, or in this case, you know, 5th root. That works out nicely. So you see the same numbers, okay? So this should be simplified to 3, okay? So now, if you want, you can pause this and then try these guys. I'm going to move on to these ones, okay? They're the same idea. So we have 5th root, right? So the 5th root of 3 times 9, right, is going to be the 5th root of 27. And then notice here I say, if it doesn't turn out, you're going to simplify. So first you simplify to the radical expression, which we did, and then we're going to put this in our calculator to find the answer, okay? The evaluated answer. So if I do the 5th root, math, right, and then I choose number 5 of 27, that's not a perfect cube, okay? So it's going to be a decimal, that's okay. They said to the nearest hundredth, that's 2 places. So this will be 1.93, okay? So I just want to make sure you can put it in your calculator. This guy, remember the index here is 2, okay? You don't see it, but it is 2, that's just a square root. So if I think about this, this is really 50 divided by 2. So the square root of 50 divided by 2 is the square root of 25, which is 5, okay? Then here, third root of 4 times 4, third root of 16, and I know that's not a perfect cube, okay? So I'm going to put that in my calculator, math 16, and that gives me 2.5, and then since this is a 9, I'm going to round that up to 2, so 2.52. And then this guy, multiplication again, so third root of 4 times 54. So 4 times 54 gives me the third root of 216. Now I know that's a perfect cube. That's going to be 6, okay? Or you can put it in your calculator, all right? This guy, a little weird, but we could still do it. Let's see. This would give us, because the denominator is bigger, so it's 8 divided by 128. So let's see. 8 divided by 128 gives me that decimal. I can hit, so I did that. I can hit math, frac, and that gives me 1/16. So this is the 4th root of 1/16. Now, if I do the 4th root of this, it's really the 4th root of this, the numerator and denominator. So I know the 4th root of 1 is just 1, okay? And then the 4th root of 16, we did we do that? Yeah, right up here. So that should be 2. Okay, you can also do the 4th root of that if you want on your calculator. Hit math, right? And then do 1/16, and you get that. Now, that if I math, that's the same answer. So what happened? Well, it only did the 4th root of 1, not of 16. So what you have to do is put that into parentheses. So if I hit math, you're going to want to do 1 divided by 16, and then you get 0.5, which is 1/2, okay? So just make sure if you have any sort of division, you're putting that in a set of parentheses, okay? This guy, this is the 1/8 root of 3 times 5. So the 1/8 root of 15, which I have no idea what that is. I'm going to do 8, math, and then 15, and that gives me 1.40. Right, because I should have that out to the hundredth, so that's 2 decimal places. This guy, since it's division, I'm going to write it, right, all underneath that radical. Then we have the square root, the index is 2, remember that's there. And then that should give me 9, which is 3. And then last but not least, we have the 3rd root, or the cube root of 27 divided by 9. So the cube root, 27 divided by 9 is 3. So then the cube root of 3 is 1.44. And that's how we multiply and divide radicals, okay? But remember, the most important thing is they have to have the same index. Okay, then you're going to actually do the multiplication and the division, and then simplify. Sometimes it's going to be a nice answer. Sometimes you're going to have to round, okay? So you should be seeing, okay, some decimals sometimes, but most of the time, hopefully they're nice answers, okay? So hopefully that makes sense. Please email me if you have any questions, and I hope you guys are doing well.